So let's look at number 2. It says, set up and evaluate the integral that gives the volume of the solid form by revolving the region about the x-axis, okay? So I have this already drawn over here, and I'm going to revolve it about the x-axis. So this is going to kind of like come out of your paper and then go back around the x-axis, okay? So you see this right here. It's creating these vertical slices, okay, that are going to show that it's going to be parallel to the parallel to the y-axis, these vertical slices, that is. So these are going to be dx, okay? So there'll be a bunch of vertical slices, and we see this one purple one that the equation actually showed us, or that the graph did, okay? So it is exaggerated. It shows a huge width, but all it is, it's representing each and every single rectangle that's going to be revolved about the x-axis, okay? So because this is an axis of revolution type of problem, these are not cross sections, okay? So axis of revolution is going to have this washer or disk method feel to it, okay? So the disk has no void, and then the washer is the one that has like a little bit of gap or empty space, if you will, somewhere within the interval, okay? So let's go ahead and set this one up. So since I'm going to revolve about the x-axis, this area is touching the x-axis, which is the axis of revolution. The entire interval from 0 to 8, it is touching everywhere. So we know it's going to be a disk because there isn't like a void or a gap anywhere within that 0 to 8 interval, okay? So let's go ahead and set up our equation. We have pi r squared, and there's only going to be one r. Because that's the area formula for the circle. These are all pi r squareds. And we know, again, that if we take the integral of a of x in respect to x, this is going to yield that volume. Okay, so that a of x equation, as far as what's the area that I'm integrating, is going to be pi r squared. So we have the pi constant multiple rule pulled out, and then we have a dx because these are vertical slices. We just have to come up with what is r represented into this problem, okay? So I'm going to put this as far as purple colors because this is my r value, if you will. And again, it's already drawn for me. Right here is my radius that's going to be kind of revolved about the x-axis, okay? So if it came out of the page, it kind of has this kind of feel to it. And then there's the back of the circle, and this is that r value. It's that radius that's going to be kind of rotated about 360 degrees. Okay, so let's look at this purple line right here. That's our r value, or radius. And looking at it just the way you see it, the top function is going to be the blue function. Okay, and the blue function that was given is in fact this piece right here. Okay, so that's the top function. And then the bottom function is going to be, so let me highlight that in orange. This is the top function, and this is the bottom function. The bottom function is the x-axis, aka y is equal to 0. Okay, so if I come over here and I were to kind of extend this and make it a little bit larger to see, you would know that the top function, which is blue, is going to be the square root of 64 minus x squared. This is the top minus, let me put that in purple because this is all my r, minus the bottom function. So let's put the bottom function in red, which is the x-axis. Well, that's y equals 0. So the top minus the bottom would give you the length of that purple. Okay, so that purple, again, let me go back to that. This purple that we're talking about is right here. That length is all of this. Okay, so pi r squared, this is the answer to this problem. Okay, so now I can just put this into my calculator, or if I was doing it by hand, I know that minus 0 doesn't matter. So it's like it isn't even needed, where I can take this out and basically just square whatever's left. Okay, so when you square whatever's left, that square root symbol is going to go away. Okay, in this particular problem, it will go away because it's squaring this square root to where all you'll have is this 64 minus x squared. That's all that's left in this particular problem. Okay, and yes, if you need to rewind that, pause it, whatever you need to, please do so that you understand what just happened. But nonetheless, the answer to this is going to be our volume in units cubed. So let's go to the calculator. Let's punch that in real quick. So we have the integral, and we do need our bounds, by the way. So let me go back to the picture. It's from 0 to 8. Okay, so vertical slices means from this vertical, x is equal to 0, okay, all the way to x is equal to 8. So we're going to say from left to right, 0 to 8 is are the limits of integration. Okay, so 0 to 8 of 64 minus x squared, and it's going to be in respect to x. So we have 1,024 over 3. 1,024 over 3, and it is units because it didn't give us a unit of measure. Yeah, there are no inches or anything like that, and it'll be units cubed. This will be our answer for this particular problem. And again, just for calculator purposes, if we wanted to see the equivalent in decimal, just press enter to highlight it, control enter, and then write 341.333. And that is how we would do this particular problem.